Now, the arrays so far, the arrays you have seen so far are what we call a one-dimensional array. Now we are going to talk about multi-dimensional arrays, 2D arrays, 3D arrays, and so forth. In a 1D array, when you create an array object, you pass in a number, and that is the number of slots. When you create a 2D array object, you pass in two numbers. Altogether, this 2D array can have 4 times 3 or 12 slots. 12 integers can be placed into this 2D array. When I declare a 2D array, notice that the variable b stores the address of a 2D array. Use two pairs of square brackets. So what is a 2D array? Now I'll show you a visualization and make things so easy to understand. A 2D array can be viewed as a table. Alright? So in this case, I'm creating a 2D array with 4 rows and 3 columns. Okay, always remember, it is always the first number is a row, number of rows, the second number is number of columns. Okay, RC, row, column, not column, row. So in this table, we are going to have, I've drawn a table here with 4 rows, 1, 2, 3, 4. Okay, remember the indexing starts from 0. So when I say row 0, I actually mean the first row. And 3 columns, column 0, 1, and 2. Okay. Now for those who have difficulty remembering that this is a column and this is a row, you can think of some way to remember that. Okay, a column, you know, when you look at columns which support a roof, okay, so that you call that a column. All right. Anyway, so how do we insert values into B? Okay, I can do something like this. B 2 0 equals to 9. This is an int array, so all the slots will store integers. Now 2 0 here refers to row index 2, that means the third row. Column index 0, that means the first column. So 2 0, this one. And I set the value 9 there. Now by default, all the other slots will contain the number 0, the value 0. So another example here, B 3 2 equals to 5. So 3 2 refers to the last cell here, and I'm setting the value 5 to that slot. Like I've said, all the other values, all the other slots will have 0 there by default, okay, unless you change the value. So same thing for retriever. To retrieve, you can do something like, you know, int x equals to b 0 1, and that will store the value 0 into x. Okay, so a 2D array can be visualized as a nice rectangle, a table. The first number is the row, the second number is the column. Now same thing, if you try to access something like B 4 3, okay, you get an array index out of bounds exception. Array index out of bounds exception, because there's no row number 4. In other words, there's no 5th row, and there's no column number 3. So it refers 4 3 refers to a non-existing cell. Now, what does length mean here? You know that for a 1D array, it is quite straightforward, right? For a 1D array, in this case, a.length will give you 5 number of slots, okay, in a 1D array. What about b.length? Now b.length gives you 4, okay, not 12. b.length gives you the number of rows. b0.length gives you 3. This one is 12, this one is 4, this one is 3. B0.length gives you the number of columns in the first row. B0 refers to the first row. B1.length will also give you 3. Okay, because this is a nice rectangular array. B2.length will give you 3. B3.length will give you 3. B4.length, no such row. Okay, there's no B4. So be careful of this. Very common mistake by beginners. B.length does not give you 12. B.length gives you 4. Now this is the first way to visualize a 2D array. Now the second way to visualize a 2D array, this is actually the more accurate way, but both are correct. You can view a 2D array as an array of arrays. Basically, it's an array of a 1D array. So here in this case, B stores the address of an array. Now this array has got 4 slots. Now each of these 4 slots will store the address of another array, and this other array has 3 slots each. So it looks like this. The diagram looks like this, something like octopus. So if I do what did I do just now? 2 0 equals to 9. So if I do B 2 0 equals to 9, it will be 2, okay, 0, and 9 is stored here. Okay, if I try 3 2 equals to 5, so B 3 2 equals to 5. I'm looking at this, 3 2, and 5 is actually stored here. Okay, if you visualize a 2D array as an array of arrays, B.length, the reason why B.length gives you 4 will be more instinctive. B.length gives you a number of slots in this array, which is 4. Alright, B0.length is actually referring to this array. How many slots are there? 3. So either way, you can visualize a 2D array as a as a table or as an octopus. Is up to you. Most people will find it probably easier to use a table to visualize a 2D array. Now let's have an example now. I've created a 2D array. Okay, 4 rows by 3 columns. I'm going to set all their values to 88. I'm going to set 88 into every single cell. So I'm going to use 2 for loops to do it. 2 for loops to do it. In I equals to 0, I smaller than B.length, I plus plus. In other words, during the first iteration, I will be 0, I will be 1, I will be 2, I will be 3, and that's it. When I is 4, it's going to jump out because B.length is 4. For in j equals 0, j is smaller than bi.length, j plus plus. And what is bi.length? When I is 0, I'm talking about b0.length, which is 3. When I is 1, I'm talking about b1.length, which is 3. So every time bi.length will be 3 in this case, because we have a rectangular array, a very nice rectangle whereby in each row you have the same number of columns. In this case, 3 columns per row. And I'm going to do this, bij equals to 88. I'm going to change all the values in all the 12 cells or all the 12 slots to 88. This works. During the first iteration, I'm dealing with B00. I'm setting the value to 88. During the second inner iteration, I'm dealing with B01, then B02, okay, and then it becomes B10, B11, B12, then B20, B21, and B22, and so on and so forth, okay. So we usually use double for loops to iterate through a 2D array. Now, I'm talking about the simple case when we have a 2D array which makes a very nice rectangle. Now, it is possible for a 2D array to be jagged, meaning that you may not have a such a neat rectangle. Now, it's possible to create a 2D array which looks like this: 0, 1, 2, 3, 0, 1, 2. In other words, it is not a nice rectangle. Okay, how do I do that? Int x, or let's call it j, equals to new int. How many rows? 4 rows, but I do not specify the number of columns yet. Okay. Basically, this will create an array which stores 4 slots. Okay. Now I can do something like this: j0 equals to new int 2. What I'm doing here is I'm creating 2 slots. Okay, this one and this one. I can do j1 equals to new int 3. j2 equals to new int 3 as well. And j3 equals to new int 1. And this will result in the jagged array which we are seeing. I'm showing you the 2 ways to depict this 2D array, either as a table or as an octopus. Alright, now in this case, j0.length will be different from j1.length, which is different from j3.length. j0.length is 2. There are 2 slots, okay, in j0. There are 2 slots in j0. This is j0. j1.length is 3. Okay, or you can look at it from this point of view. j1.length is 3 because there are 3 rows, there are 3 columns in this row. So in this case, if you use in this case, this value may differ depending on what is the value of I. So that's what we call a jagged array, not so rectangular array, but some people do make use of this. Okay, it's possible. Now, we can always create a 2D array of employee objects. Okay, it doesn't have to be a 2D array of primitive types. You can create 2D arrays of any type of object reference types: strings, student objects, car objects. Okay. The difference is that for object reference types, each slot here will be able to store the address of that object, okay, instead of the actual primitive value.